Hello, geometry students. Okay, so today we're going to step away from trigonometry for a minute because I want to put a trigonometry project up for the weekend. So I want to give you some time to do this. It's not going to be a huge project, trust me. And I want to be respectful of everyone's religious practices and when you're going to take off. So you'll have plenty of time to do an assignment. I didn't want to rush you to get it done before the holiday. So you can take your time, treat it as a quiz, but knowing that you can take as much time as you want on it. Okay, so let's look at something here. So now we talk about transformations. Now transformations is something, well, a transformation is something when we change something from one thing to another. Now it doesn't mean necessarily we change the shape. Well, we could change the shape. We could change the size. We could change the position. Now, we're going to study a whole bunch of transformations, and I think it's going to be a little bit interesting doing this without graph paper. So we're going to do things a little bit more advanced than normally. Normally I say, well, you could do this with graph paper, or you can do it without graph paper. Well, just in the being fair, I'm going to say let's do it all without graph paper. I usually don't teach it this way, but drastic times, drastic measures. So, today's lesson, there's no real need for graph paper, but if you happen to find some floating around your house, old bag, you got a couple of those, you can use it. Don't necessarily have to use it. I'm going to teach us how to do it without anything. Okay? We might look at graphs. We might analyze a graph. But the one thing we are not going to do is I'm not going to require you to make a graph. So, maybe a little bit harder, but I think you'll be better for it in the long run. Okay? So, here we go. It says, does the transformation appear to be an isometry or not? Now, this is my pre-image. Okay? So let's take them notes. This is not really going to be a very math-heavy lesson, so let's take notes. Now, first definition I want to say. I want to say a transformation. Now, my definition is a change in shape, position, or size of a figure. Copy my notes. That's all you're doing. So a transformation, okay. So we can transform something. We have an image, we could do something to it. Now, the original figure, so if I'm going to do a change, the first thing, the original figure, we call the pre-image. Now, pre-image, if we ever think of preview, previously, let's see, I can't think of another one. Why can't I think of another one? Previously means first. So a pre-image is number one. That comes first. This image is what comes after we do the change to it. So in this case, when we're looking at this shape in A, this one was originally. When you looked at it again, it was this way. So it started out like this, and it went like this. Now, so the resulting image, I'm going to call it the resulting image, which is what happens after the transformation, or the resulting figure, it's just called the image. So I have a pre-image and an image. And the final thing is an isometry. Now this is a word they often test on the Regents. An isometry is a transformation in which the image and pre-image are congruent. Now, what is congruent? Our favorite little congruency symbol. We always say equal, but remember, more specifically, congruent means same size, same shape. So we always have to ask ourselves that when we're doing this, is it an isometry? Isometry is a very important word here. If I move it and it remains the same size and shape, it's called an isometry. So let's look at two basic questions. They ask this, image 1, pre-image, and this, are they an isometry? Well, I'm looking at it and I say, well, how could I get this image over here? Well, they asked us to explain, so we'll explain this. I went ahead and I cut out a perfect recreation of this. This little yellow thing here, maybe hard to see. I apologize if it's hard to see, but I only had yellow Post-it notes, so otherwise it would have been white. So, you know what? Hold on. Instead of doing that, I'm going to do this. Look, I'm going to color it in. Coloring it in, coloring it in, coloring it in. So it'll have some texture to it. I'm not being perfect here. I'm not trying to color it perfectly. Now, there we go. Now we see it a little bit better. So I made this shape. If we remember, this is a kite. It looks to me like it's exactly a kite. Everything works out. Now the question is this exactly the same? Well, how can I get from here to here? Well, there's one way I could do it. I could take this little point here, and what I could do is like a clock. I could rotate it along the clock this way, or I could rotate it along the clock, if I'm starting here, this way. I could go one way or the other. And if you see, they match up. They're still the same size. Now the shapes may look different because I've done something to them. So, one, yes, it's an isometry. Because it's a rotation, and rotations is just what I did. That rotation, and, and, what is it to me? There's another movement we can do. Or, I'm going to say or, because it could be either one. It's a rotation or a reflection. So I'm going to put a big square around there. Rotations are isometries. Reflections are an isometry. Now, if you want to think about it, a reflection means, like, if I put a mirror here along this point, these two faces, if you want to say this is a face, they're looking at each other, they're flipped. So you can literally, reflection literally means you flip it. You take this, I'm going to take it here, I'm going to, instead of rotating it like a clock, this time I'm just going to go flip back over there. Perfectly flip back over here. So you just flip and flip. Rotations are isometries. Reflections are isometries. Now I look at this little guy here. My image and pre-image on this triangle. And of course, I made a model triangle that I'm going to color in now, which you'll be able to see as I'm talking about this. Look at these two movements. What do you think? How would you get that triangle from here to there? That's a really interesting question. How would you get there? Well, the first question, is it an isometry? Well, we're going to prove that in 1 second. Well, I can prove it by measuring and make sure all the sides and angles are equal, same size, same shape. So that's definitely one way I could do it. But I'm going to use my model here to show you. Fits perfectly. The pre-image, remember, the pre-image is where it starts, and where it ends is what we call the image, here. And you see it fits perfectly in both, my model triangle. So this triangle gets from there to there, but how did I get from there to there? Well, I had to do a couple of things. Could I have reflected? Well, if I were reflected, I would have just taken this thing and flipped it over and I would have had something like that. Well, that kind of looks like it. So it's a reflection, and part of it's a reflection, but it's also something else. To get it here, I would have to go up and I would have to go across. Think about it. So after I flipped it, I have to go up and go across. That, my friends, is what we call a translation. So yes, it's an isometry because it's a rotation, we already know that, and it's a translation. So we take the same image and we move it, okay, up to the right. You can move it anywhere, but we can't just say it's a translation, because if I just moved it up and to the right, I got here, they wouldn't match up, see? I have to flip it. So the types of movements that are isometries are rotations, reflections, and let me spell this right. You know, I'm not an English teacher. I'm going to say translations. So you can flip something, you could rotate something, and you could move something. Now, are there any other movements? Well, one of the things we're going to learn about is dilations, right? So it'd be like if I looked at this, let's look at this triangle, and then all of a sudden, well, let me zoom in. I zoomed it in. I'm going to zoom it in by moving the paper, so don't get too confused here. I look at the pre-image. Look how it is, right there. And all of a sudden, I move it up. Oh my God, it's huge, right? Here, let's get close. It almost takes up the whole page. That pre-image, right? So a dilation is not an isometry, which is really what a dilation is, changing the size of something. Okay? And we said for a congruent, same size, same shape. So as long as it's the same shape, it's an isometry. All right, that was a long one. I'll talk to you in a minute.